So hello everyone. Today in this video we are going to talk about covariance and correlation. In statistics, these two concepts are really important, and we will see why we use covariance and correlation. So the first we will go with the definition, and we will see some example how it's work and what is the real world example. Okay. So the first definition is like a covariance and correlation are two statistical measure used to understand relationship between two variable. If there are two variable, suppose there it is data, there is two we want to know the relationship between two feature, there it is data of size of house, okay, and some price, and we want to know the relationship between the size of house and price. What is the relation? There it is negative or positive. So for that we read about the covariance and correlation. Okay, they help explain how change in one variable are associated with change in another variable. What it does mean? It means if size of house is increasing, then what the price, how the price of that house is affected, either it is increasing or decreasing, right? Like decreasing or increasing, right? So that's why we use the covariance and correlation. So in these two terms we will first see about covariance, then we will move forward with the correlation, right? So the covariance measure how much two random variables change together, if size of a house is increasing 1 unit, then how much price is increasing or decreasing, right? If the both variable increase or decrease together, the covariance is positive. If size of house is increasing and price is also increasing, then the covariance is positive. If size of house is decreasing and price of a house is also decreasing, then it's also a positive covariance, right? If the one variable is increasing and second one is decreasing, then this one is the negative covariance, right? If first one is decreasing and second one is increasing, then it's also a negative covariance. Understood? So yeah, let me draw some example so that we can see clearly. Suppose there is a x variable and y variable. Okay, so there it is 2, 3, 4, and sorry, 2, 4, and 6 and 8. Okay, and y is 3, 5, 7, and 9. Okay, so what is happening in this? We will see either x is increasing, then how y is reacting. If y is also increasing, then it is positive covariance, right? If x is increasing and y is decreasing, then this one is negative covariance, right? If x is decreasing and y is increasing, then it is negative covariance, right? If x is decreasing and y is also decreasing, then this one is positive covariance. Understood? Yeah, so like this we can see if it is the relation between two variable is positive or negative. Understood? Yeah, so let me draw some real world example, size of house size of house and price. Okay, so what do you think? If size of house will increase, then how the price will affected? It will decrease or increase? If size of house is 1200 square feet, then the price of 40 lakhs. Understood? If size of house is 13 lakh sorry 1300 square feet, then its value price is 50 lakhs. If the 1500 square feet, then it's 25 lakhs. So what you can say about these two variable? Uh, this is the covariance of these two variable associated with each other is positive or negative. We can say positive. Why? Because when size of house is increasing, price is also increasing. When size of house is decreasing, then how price of house is also decreasing. So if the data is less than 100, 200, 300, like this one, then visually you can see, and we can see and tell about the data that it is positive positive correlated or negative correlated or not correlated. But there are a lot of data, then we use some formula for the covariance and some Python thing we will see later. So the to calculate the covariance, what is the formula? So the formula for the covariance is sigma I equal to 1 to n. N is number of data, okay, yeah, or number of column in a table. Okay, so xi minus x bar into yi minus y bar divided by n minus 1. N is number of data or number of column. Okay, sorry, number of row. Ahead what suppose we want to calculate the covariance between only one variable, like we have x and we want to calculate the covariance x with x. Okay, so what will be the formula? I equal to 1 to n and xi minus x bar into and xi minus x bar divided by n minus 1. Okay, so what will be? It will be xi minus x bar the whole square divided by n minus 1. It is nothing but covariance of x, sorry, variance of x. Variance of x is equal to I equal to 1 to n and x minus x bar the whole square and n minus 1. This is the variance. Okay, yeah, we can see here what is the xi. So the xi is data points, data point of random variable x. Understood? Random variable x. And what is x bar? So, what is the x bar? X bar is the sample mean of x, uh, and yi equal to data point of random variable y, right? Random variable y. And what is y bar? Y bar is sample mean of y, mean of y. Understood? So like this we can calculate the covariance, and as we know why we use covariance, to know the relationship between two variables we use covariance and correlation. Okay, so yeah, let me take some example and calculate the covariance. Understood? So there it is, a student data set. So how much our study a student x, and what exam score y, right? If 2 hour a student read, then he get 50 marks, 3 hour 60 marks, 4 hour 70 marks, and 5 hour 80 marks, and like 6 hour 90 marks, right? First, without calculating the covariance, what we can say about this data? We can say about this data like this is the positive covariance. Positive covariance. Why? Because if the study our study is increasing, it is like exam score is also increasing. If our study is decreasing, then exam score is also decreasing, right? So without calculating the covariance, we can say that this is the positive correlated data, right? But we need to we are taking the example, so we will calculate and see. So the first what we need to do, so covariance of x and y equal to sigma I equal to 1 to n and xi minus x bar into yi minus y bar divided by n minus 1, right? So what we'll do, first we will calculate the x bar and then y bar. So x bar equal to 2 plus 3 plus 4 plus 5 plus 6 divided by 1 2 3 4 5 5 4. Y equal to, so y equal to, let me see the first data, 50 60 70 80 19. Okay, so 50 plus 60 plus 70 plus 80 plus 19 90 divided by 5, it is like 17 20, yeah, it is 20, right? And then we will calculate the covariance. So the covariance will be 2 minus 4 into 50 minus 60 plus 3 minus 4 into 60 minus 70 plus 4 minus 4 into 70 minus 70 plus 5 minus 4 into 80 minus 70 plus 6 minus 4 into 90 minus 70, right? Just a minute. Okay, right. Divided by 4. 5 minus 1 would be 4, right? Then we will calculate, and you can do that covariance of x comma y. So it would be 20. You can calculate and see, right? So what does it mean 20? So it's positive, so we will say that, and we can say that the x and the y is positive correlated, right? Positive correlated with each other, right? With each other, right? uh, yeah. So the, but here what is the problem? Like there it's first problem is that the covariance varies from covariance of x comma y varies from minus infinity to infinity, right? This one, yeah. The problem is covariance varies from minus infinity to infinity. So we can't say about the covariance like how much it is correlated or how strongly correlated it is. Understood? And second one is that it is there it is unit. Okay. So it is a unit base. If the a study hour is in in hour, and exam score is in what you can say in marks, right? So the unit will be hour into marks, right? Something like this. Or there it is A's into like A's and weight will be then it will be ER into centimeter, something like this. So we mix up the two unit each other, which is worthless. That is not the meaning of this unit. So this is the drawback of covariance. That's why you there it's come the correlation. So correlation. Okay, what is the correlation? So the correlation is the standardized form of covariance. Understood? It is the standardized. So the let me first, yeah. So the correlation varies from -1 to +1, right? What it does it mean? If correlation a correlation is near to 1, then it is the positive correlated, a strongly positive correlated. If it is near to -1, then it's a strongly negative correlated data. If it is 0, then it is not correlated. So here we can say that how much it is correlated with each other, but in the covariance we can't say anything. Understood? So the what is the formula of correlation? So correlation of x comma y is yeah, covariance of x comma y divided by a standard deviation of x and a standard deviation of y, right? This is the standardized form of covariance. Understood? Okay, and yeah, and let me write one thing more. First one is the more the value towards +1, the more positive correlated x and y is, right? The more positive correlated x and y is, right? And second one is the more like the more the value towards -1, the more negative correlated it is xy, right? Correlated it is x comma y, right? So yeah, this one is about correlation, and we for like previously we read about covariance. So this all about the correlation and covariance, right? Now I have write some code in the Python, so I will show you that how the correlation looks like in the heat map. So yeah, yeah, yeah. Firstly, what I did, I have import the NumPy as NP and the Pandas as PD and C1 as SNS and matplotlib as PLT, right? And then I have I have set the seed value like 42, which all usually use the 42. Number of sample is n equal to 200. So I am creating the synthetic data to visualize the correlation between the features, right? So for the see the correlation, we need to use the heat map. First, I'm going to like size of house, how it will be np dot random dot normal. It will be normally distributed data. So 1500 and 300, it will be lie between this and n the number of data set. Like this, I have location, number of room, number of people, and then price. So the price price will be correlated with which one location, number of rooms, and size, right? So the price formula is this one. I have written this. Then I have created a data frame. So data frame I have created using the pd.data frame, and then I have given the all the columns, and then I print data.head, which is this one, data.head, and the size of the house is this one, location and number of room and number of people live in rooms. So if you don't know about data.head, data.head gives the first 5 rows of the data set, right? Okay, then we I create a figure of fixed size 10 and comma 7. 10 and 7 means sorry, yeah. So this size is 10 7 overall the size. Then I created the heat map, data.correlation, and I know it is equal to tree and all the thing. Okay, and then PLT the title and PLT dot so so this one is the correlation heat map. Understood? So the price, just a minute. Price is correlated with size of house. 0.60 means it is correlated. You can't say strongly, but it is correlated. The correlation and price is correlated with 0.60. Number of room and price is like correlated with 0.38. It's not the correct and accurate thing, but yeah, we can visualize this type, the correlation of the feature of any data set. Okay, so yeah, thank you so much for watching.